so I'm recording. Now, can I close this? I think I'll upload the recording of this session and previous session all together today or tomorrow, hopefully. Okay, back to this example, and then finish with the ER modeling. We can move to normalization. This is an example of your textbook. So if you have ever read your textbook, this example is extensively used there. And that is why in my class, I'm using another example like a student registration to give you like different examples. I highly recommend you to get yourself familiar with this example, because this is very similar to, like, in terms of its core entities, right? It's very similar to your assignment 1. It's very similar to your group project. Same thing you have there, right? For example, you have a product in your, all the cases or all the examples of the group project, they have some product, they have transactions or orders, they have customers, right? You may have also product category or so on. So these are some of like your main entities here. Now, as you see, there is a many-to-many relationship between product and transaction. Again, okay, yeah, sorry. Yeah, I said these are like changed. Okay, so these are the main entities that you'll see, right? Product, customer, like maybe product categories, orders, or transactions, right? And then what you see here is not complete, right? What's the problem? What is one problem here? Not a real problem, but I ask you to do it in your exam. Yeah? Yeah, many-to-many relationship is not shown as associative entity. So I want you, like in your exam and your assignments, I want you to show it as associative entity. There is a many-to-many relationship between product and sale transactions, right? There should be an associative entity added here because we can't handle that, right? We can't handle like many-to-many relationship in like relational databases. And so each vendor can supply one or more products, right? But each product is supplied by one and only one vendor, right? This is how you, and as you see, there are like primary keys or unique identifiers for each entity. This is exactly what you have to do. And how should we show like also foreign keys in your ER model? Should you show foreign keys in your ER model or not? And why? No, we don't need to show foreign keys, right? What are foreign keys? Primary keys in another table. Why do we use them? To link the tables, right? Why do we use them to link the tables? Because there's no other, like, this is a conceptual model, right? Conceptually, you can show the connection, right? You can, like, for example, use like these relationships, these signs, right? To show the relationship between these two entities or these two entities. So this is conceptual, so you can show it. In your actual implementation, you need to connect the tables, so it's not conceptual anymore. You have to use something, right? That's why we use foreign keys to connect the tables together. So in your ER model, you don't need that, but you have to show the unique identifier for each entity, at least like 3-4 attributes for each entity. If there is an attribute that should be like composite, derived, or any other type, you have to specify that. Let's say, for example, you have an address, okay, in your ER model. I want to see that as a composite attribute, right? If you have, for example, a phone number, I like to see that as a multi-valued attribute, and so on. And yeah, so this is just a conversion to relational schema. So as you see, there is no problem if you don't have that automatic button to automatically create a relational schema from your ER model. You can still create that using ERD+. And it's better, you better learn this. And in your relational schema, as you see, now you will see like all the foreign keys and everything. And as I said, even if you don't use associative entity in your model, then here you have to show the third table. But just for like keep things consistent, I ask you in this class for all the examples, projects, assignments, exams, everything, please use associative entity, and also here this intermediary table. For instance, we don't have the include entity in your model, right? So as you see here, include is just a relationship, right? But because this is a many-to-many relationship, in relational schema, it added like this third table, right? And at this point, you also want to show the foreign keys, right? Because these are your tables, are going to be your tables. So you want to see what are primary keys and foreign keys in each table. Looking at like foreign keys, then you will realize which tables it's connected to, right? For example, product is connected to vendor and category, right? You have vendor ID and category ID as foreign keys, and so on. Yeah, you had a question. Mm-hmm. No. We have a multi-valued attribute like phone number, right? Why should we design it as a weak entity? So multi-valued attribute is an attribute, right? So it's attribute that has multiple values for each record, right? For example, we say student phone number. So for each student, we may have two phone numbers, right? Home number, cell phone, or maybe someone has like two cell phone numbers. And I was talking about how to actually show that. We know how to show multi-valued attributes, like for example, let's say phone number. We know how to show it in your conceptual model, in your ER model, right? But I was talking about when you convert it to your actual tables, right? How do you design this? So for example, you know that each entity is converted to a table, right? So for example, we will have a student table, and we said each attribute will be the column of the tables, right? So we have a student ID here, name, and let's say phone number. Now there is an issue here, right? Because then for each student, let's say student ID 1, Mona, right? We have multiple values. And we said this is against the atomicity of relational databases, right? We cannot store multiple values here. And I was explaining what we can do. So for example, one way is to design it as a separate entity. So you can think of multi-valued attribute when you convert it to your relational schema and then your tables. You can consider a separate table for multi-valued attributes. Then you can have another table with, let's say, a student ID, right? And phone. And then having like phone numbers for each student here, store it here. And then you can use maybe surrogate key as a primary key, okay? But you cannot have multiple values stored in one cell. Could be, yeah. But in general, you don't have to. You don't need actually to memorize. Like if it's like, for example, multi-value is always weak. You can think of it like case by case, because then if there is an exception, you won't like do any mistake. So for weak entity, I recommend you to always check for primary keys. If it doesn't have its own primary key, and it depends on another entity, for example, the case of section in York University, right? The section themselves, they don't have any meaning. Or for example, storing dependent information of an employee. So we don't have dependent ID similar to what we have for employee, right? We have employee numbers, employee ID, student ID. We have product numbers. So these are the things for which we have primary keys. And sometimes if we don't have, we can use surrogate keys as the primary key. So it has two conditions. Not only it doesn't have its own primary key, but it also has to depend on another entity for its existence. Yeah. Sorry, car. Mm-hmm. You mean a shopping cart? Yeah. Okay, so in each shopping cart, you can have several products, right? So you are now adding the customer. Okay, so that's then another entity. So these are like different relationships between like different entities, right? So you have like, are you now talking about the relationship between product and shopping cart? Okay, so what is the type of relationship? So each depends on how do you define that. For example, we say each product, right? Each shopping cart can have one or more products, and each product can appear in several shopping carts, right? Because then we have one shopping cart maybe for me, then another shopping cart for another person. So each can appear in several shopping carts. And then again, do you also have a relationship between customer and shopping cart? Okay. So what is your question then? It was only the relationship between product and shopping cart? You thought it's many too? No, it's fine. I just wanna like hear what you were thinking. Did you think? Mm-hmm. Yeah. Yeah, and again, everything depends on the exact case or business that you're defining, right? And like even if you don't, as I said before, later you will face issues in your actual implementation, and then you have to go back and correct your design, and that's fine. I'm talking about like in real world cases, like for projects that you have. So maybe you don't, as I said, maybe you don't add associative entity between like a many to many relationship. But then how do you want to implement that in terms of like tables, right? Then you end up with like multiple values in both tables. So you think of adding a third table. And that's why conceptually we add associative entities. So what is that? It's just like something conceptual, right? In fact, that's a trouble that we faced in the implementation, that we thought, okay, let's add a third table to a store like this and get rid of like these multi-valued issues, like storing multiple values in one cell. And any more questions? Yeah. Mm. Don't get confused. Okay, but maybe I explained too much. Just whenever you have multi-valued attribute, show it. Let's keep things simple. Show it like this in your conceptual or ER model. That's it. This is how you show multi-valued attributes, right? And so there are like a few things that you have to remember in terms of your ER model. This is, for example, associative entity, right? This is weak entity, and then this is regular entity. And then in terms of attributes, this is your like normal attributes, regular attributes. This is multi-valued attribute, like phone number, right? And then you have also one composite attribute like address, which you show with these like parentheses, right? And then you have several, for example, components for it. And yeah, and then you have derived, right? Which means derived attribute, what does it mean? Yeah. Yeah, so we have some information maybe in your tables, but you are constantly, maybe later in your analysis, you're constantly using another like metric or something that is calculated based on what you have. For example, you have date of birth of employees, but you constantly deal with the age, right? You want to, like, for example, maybe retrieve employees who are, for example, older than something, or then if you want to like use age frequently and you don't have age in your table, you only have date of birth, you can add that, right? And then it's called derived attribute. But the age is not the only example. We can have anything, right? Maybe you have like a salary, right? And then you have a commission, and then you can calculate the total income, add another column as total income, which is the sum of like these two columns. And this will be later all your tables. And this is just the advantages and disadvantages of relational schema and just some more models. Okay, so let's go to, I want to just at least like have like an introduction to normalization today. So, what is normalization and why do we need to do it? So, like, if I want to summarize it in one sentence, it's the process of breaking down a large table into some smaller tables, or getting rid of dependencies. So in order to understand normalization, I think the first step is that you understand the problem in the tables and why we need normalization, right? So the problem is dependencies. So we have to know the different types of dependencies or anomalies that can appear in the tables so that we may need to do normalization. So let's say I have a table like this. Okay? Have a table like this. We have a student ID, name, course ID, course name, instructor, instructor, office. Okay? What is the problem here? Or do we have any problem? Anyone else? Someone new. Yes. Angela and Alice has the same instructor. So why should it be a problem? We can have many students having the same instructor. Oh, I really like that most of, like, more of you are raising your hands, yeah. No primary key. That's one problem, right? What do we want to define as a primary key here? Yeah.
We're storing student information, course information, and instructor information all in the same table.
Thank you. Yes. So several problems, but all those problems are because we are storing information about different entities into one table, right? That's why we have to think of, that's why actually I said your ER modeling and your design part is the most important part of database implementation. Because if you come up with the correct design, then everything is very easy, right? You just have to translate that into tables and you won't have any issues. But if your design is correct, if your ER model capture like the main functionalities of your design, then you're okay, right? You just have to translate that. Now here we are storing student information, course information, and instructor information all in one table. Now, can you think of possible issues in terms of later if you want to, for example, insert new data into your tables? If you want to update some information in your tables or delete some information, in terms of insert, update, delete, what kind of anomalies we can have? Yes. So it was we may lose information because it's all linked together. There is no separate table encoding that information. We delete this, we will have that. Yeah, that's one big problem, right? And when you think of it in like this table, like is very small one. My slide doesn't have more space. In reality, your table might be much larger, right? You may have like millions of rows, like many more attributes, and then updating like many like unrelevant fields just because of one value that you want to update is like really inefficient, right? That's only one issue then. Now, what if you insert a new course? Let's say you want to insert ECS 4412. Yeah.
Do we need a student to do that? Or like do we need basically a new entry so it causes a lot of issues with that?
Sorry?
Because you have a new course, but all of it's linked together. To add that new course, you would also need a student not currently enrolled in it.
Yeah, that's another issue, right? What else? So this is, for example, the insertion anomaly that your friend correctly mentioned, right? For example, also, if no student has enrolled in a course yet, we can't add the course or instructor information. So let's say we want to introduce a new course at York University, but we haven't have any student yet, so we can't handle that. Or what if, for example, someone wants to drop a course? So in terms of deletion anomalies. So let's say you want to drop, for example, Alice wants to drop this course. What is the problem here? Yeah.
The whole course wouldn't be present in the database anymore because right now she's the only one taking it.
Yeah. So if you drop the database, if Alice dropped the database course, since in our small like table, Alice is the only one like taking this course, then you will lose like all other information, like for example, this course information, the instructor information, right? You are like losing all information that you don't want to lose. So this is deletion anomaly. So if all students drop, for example, 3421, then we lose the course and instructor details as well. I know like some of like these examples may not seem very like feasible or practical. For example, you may think, okay, no, not all students will like will drop a course, but this is just an example, right? It could be like different things. The only thing that I want you to understand is that you want to delete something, but then you're deleting all other information that you don't want to lose, right? Or you want to update something, but then you have to like you end up with updating maybe hundreds of other like values, right? Which is inefficient. So what if, for example, this is in case of update that your other friend mentioned? For example, this is one example. What if Dr. Brown wants to change his office to 105? Then you have to update multiple rows, like in this case, 2 rows, but in reality, it could be hundreds of rows, right? And okay. Now, back to the first slide. I told you normalization is the process of organizing data in a relational database to minimize redundancy and ensure data integrity, or breaking down a large unorganized table into smaller related tables following rules of normal forms. So in like short, it's the process of breaking down your larger table, which includes a student, course, instructor, like all this information, right, into separate tables. Now, I would suggest you consider like a separate table for each entity, right? For instance, one entity is instructor is a separate entity, right? It has its own attribute, it has its unique identifier, so there should be a separate entity for that, which means you should have a separate table for instructor. On the other hand, course is the same, right? Course has like a unique primary key, like has a unique identifier, has its own attributes like course ID, course name, etc. So it should also have a separate table. And the same for the students. So we should have like at least like 3 tables to store all that information that you've seen in that slide instead of just one table. In that case, if, for example, Dr. Brown is updating his office, right, then you only deal with that instructor's office, right? Not like updating everything. And if, for example, you want to, like, for example, a student drop a course, right, then you don't lose that course information. And so I'm going back to that example later, but this is the definition. So far you should be able to understand at least this part, right? And now about data integrity, like minimize redundancy. Now you know why it minimizes redundancy, right? And data integrity, we'll talk about it a lot. Now we have like these three types of anomalies. Like insertion anomalies means cannot add a record or row because of a missing value for one or more fields. Deletion is the deletion of a record cause an unintended deletion of information, and update anomalies is updating like many unneeded fields that you don't want to actually update. So these were the examples of each, like for example, insertion anomaly, or delete anomaly, or update anomaly, right? So we have seen that. Now, how normalization prevents these anomalies? So one way, as you see here, we have a separate table for course, separate table for instructor, and a separate table for a student. Now, I didn't have more space here, but like even with these two tables, now you see how it helps to address those issues, right? Now, this one is a bit, can you read that? Okay. So now in this table, this is a non-normalized table, right? This is not normalized. What is the problem here? Anyone else? What is the problem? Anyone new? Yep.
You cannot add that new course in biology because we're lacking any students that can go there. So it's like anomaly.
Yeah. What else? Yeah.
Because it's not both the students and their advisors able, I think it could be able to change or not to say that every instance, but they have to change.
Yes. Right. So these are like, again, examples of update, insert, and like different anomalies that we have. So we understand, okay, this table needs to be normalized, right? This is not normalized, and we need to normalize it. For example, now, if like this person, Matthew, changes his advisor, let's say his advisor is Baker right now, right? Now, if he changes his advisor to Tang, then we need to update advisor email as well, right? Or for example, if you delete this student, right? Because if you see no other student has like the same advisor, right? So if you want to like delete this student, then you unintentionally also delete like the advisor information and his department information as well. Third problem, we cannot insert a new department because both the student and advisor data are missing, right? So let's say you want to you build a new department at York University, Department of Biology, right? You can't add that because there are like all these missing values here. Now, here, sorry for like the poor quality, I explain you. This is the department table, this is the advisor table, and this is the student table. Now back to this problem. So first name, last name refers to a student first name, last name, right? And then you have advisor, last name, email, and then department. How many entities do you see here? How many entities? Or how many tables? 3, right? So advisor, a student, and then department, right? So these are like 3 entities that we should have, so different tables. So here you see like a separate table for department, separate table for advisor, and then separate table for the student. Now, for example, can insert department, right? Because no advisor or student data required. and then we can change a student advisor as needed. Or for example, we can delete this student, because now if we delete this student, these are all student information, right? We don't lose like department information or instructors information. Now, very quick introduction of dependencies, and then we'll practice with like dependencies and normalization next session more, and maybe like do a code together to practice more. So first I read this, and most probably it's confusing, and then I explain. Given a relation R, what is a relation? Like a table, right? Attribute Y of R is functionally dependent on attribute X of R if and only if, whenever two tuples of R agree on their X value, they must necessarily agree on their Y value. And then we write Rx, right, defines Ry, or Ry depends on Rx. Now, R is your table or relation. All it is trying to say is that you have a table, and there is a dependency between columns of the table. So this is all that is saying, right? So this is your relation or table, right? And you're talking about the same table. And this is attribute or column X. This is attribute or column Y. You read this, for example, let's say you have table 1, column 1, right? Defines table 1, column 3. This is something like that. Now, either you read it like this way, for example, Rx defines Ry, or Ry depends on Rx, okay? Now, let's see what does it mean. When the value of one or more column in each row of a table uniquely identify the value of another column in the same row. So, for instance, we have, look at this table. We have a student ID, a student name, course ID, course title, and grade, okay? So, always primary keys can uniquely identify each rows, right? So for example, if I tell you this student number, you can give me the student name and all other student information, right? Whatever you store in that student table, right? Is that correct? So a student ID can uniquely identify student name. Is that correct? Yes. Course ID can uniquely identify course title? Yes. So we say a student ID can uniquely identify student name, or a student name depends on a student ID, okay? So there is a dependency between a student ID and a student name. What do we mean by that dependency? Because a student ID can uniquely identify student name, right? Same is for the course. So always, all the columns of a table depends on the primary key. That's I think obvious, right? Because always primary keys can uniquely identify each rows, right? So that's one dependency. It's a full key dependency. We have 3 types. Full key, which doesn't cause any problem. It doesn't violate any, like, doesn't cause abnormalities, like this. Your table may be still like normalized, so this is okay. Full key dependency. Then we have partial dependency, which I explained, and then we have transitive dependency. Now, our focus mostly is on, like, these are causing issues: partial dependency and transitive dependency. So first, you have to know what dependency is, which I explained, right? For example, we said a student name depends on a student ID. Course title depends on course ID. Now, can we say that a student, course ID depends on a student ID? Like giving a student ID, can you identify the course? If I tell you, for example, a student ID 1, which is, for example, Mona. Can you tell me what course it is? No, right? So there is no dependency between like these two. Now, between, for example, course title and a student name. Having a course title, can you identify the student name? A student ID and grade. Okay, so let's see this. So we have like this table, a student ID name, course ID title, and then grade. And then we want to talk about like these dependencies. So always, when you want to identify the dependencies and the type of dependencies, first focus on the primary keys and identify the type of primary keys that you have, okay? So if you have a single primary key, let's say it's a student table. A student table, does it have a composite primary key? No, it has a single primary key, and that is a student number or a student ID, right? So always, if you have a single primary key, you will not have any issues with partial dependency. Why? Because as the name suggests, it's a partial dependency. That means you have a composite primary key. Now your primary key is composite, can consist of 2 columns, 3 columns, or more, right? For example, enrollment, right? Enrollment has a composite primary key. Now, if you have a composite primary key, then there is a chance that you have partial dependency, which means, let's say this is a table, and then these 2 columns form a primary key. It's a composite primary key, right? Now you have another column here that depends on only one of them, not both. If it depends on only one of them, we call it partial dependency. And don't panic, I'm going to explain all this more. This is just like an overview. Now, depending on, after I teach you how to define like these types of dependency, right? Right now, I don't expect you to know how to identify that. But depending on like whether you identify partial, transitive, and so on, then you can identify the normal forms. That's why I explained this, like just provide an overview of this first, because, for example, if I just tell you this slide, 1NF means no repeating groups. 2NF or second normal form means no partial dependency. So you have to understand what partial dependency is, right? 3NF or third normal form means no transitive dependency. So you also have to know what transitive dependency is. And then you don't need the rest, okay? So for the scope of like this class, you only have to know until 3NF, and we normalize tables until 3NF. Now, first normal form means a table, each, actually, we go back to the atomicity of the relational tables, okay? So 1NF means we don't have any repeated groups, or we don't have multiple values stored in a cell. So if I, for example, show you this table, the one on the top, we have a student ID name, a major, course ID, course title, and then instructor. So is this table in 1NF? 1NF means no repeated groups. That is, you don't have multiple rows repeated, and you don't like have multiple values stored in one cell. So is this first normal form, this table? No. So as you see here, the first row, what is the first row? You have this a student ID, and a student name is William, right? And then you have like different like courses and different instructors, right, for the same student. Can we do that? Can you store multiple values in one cell? So this is one row, right? So this is like this table is not even in first normal form. So first normal form means you do not have repeated values. You do not have you don't have repeated groups. You don't have multiple values, and all values are atomic. Atomic means only one value in one cell. So for example, instructor location, we cannot store like 2 locations in one cell. So this is not in 1NF, okay, because of like these repeating groups. So now here, you can, for example, separate it to two tables. Let's say separate it to a student table, one table for storing student information, another table to store, let's say, the course information. For example, only storing a student ID with the course and instructor information. Now, this is like an enrollment table, right? Where you have a student ID, course ID. It's like enrollment table, right? Now look at this enrollment table. Is this in 1NF? Is this first normal form? What is first normal form? You should like tell me like really fast, because you have to check whether it has repeating groups, which doesn't, whether it is like storing multiple values in a cell, which doesn't, right? So is it first normal form? Just look at it. 1, 2, 3. Yes, no, it's not. Yes, it is first normal form because we don't have repeating groups like this one, right? And we do not have multiple values stored in a cell. So this is a first normal form. Now let's go to second normal form. Second normal form means the table is already in 1NF. Okay. So 1NF. One NF means atomic, no repeating group. Okay, so this is 1NF, which is easy. And then 2NF means already in 1NF plus no partial dependency. Okay, so 2NF means the table is already in 1NF, plus it doesn't have partial dependency. What is partial dependency? Let's say you are talking about enrollment table here, okay? What is the primary key here? A student ID and course ID, right? We have a composite primary key. Do we have any column, any non-key column here, like any of like these columns, that depends on only one of like these? Thank you. Course title, for example, right? Course title depends on a student ID or course ID? Course ID, right? Because if I tell you course ID, you can tell me what this course name is, right? ECS 3421 is database, right? But if I give you a student ID, you cannot identify course title. So now we have a dependency, right? Now this column depends on only part of our primary key. So we have partial dependency, means there is a non-key column depending on part of our primary key. Just a question and then you can leave. If we have, like, let's say, a composite primary key in a table, can we say that we have partial dependency? Not always, not necessarily. Now, if we have a single primary key, can we definitely say we don't have, like, any partial dependency? Yes. No way. Like the definition says it should depend on part of your primary key. So if primary key doesn't have parts, right, it's just one, then there is no way to have partial dependency. So enough for now. Have any questions? Sorry? No, it is not 2NF. This one? So a student ID will be primary key, so it's a single primary key. So we cannot have any partial dependency, right? And it's already in 1NF because we don't have repeated groups, right? So it's 2NF. Just give me a second to pause the recording.